Hi chemistry scholars, today we are going to review the mole highway. This is all review from material that we learned at last class. So if you are still struggling with this material, make sure that you are reviewing notes, maybe rewatching this video and trying the bell work again. You could talk to a friend who understands it well, or even attend my Tuesday morning office hours, or feel free to send me an email. We will jump in with this bell work. Please make sure you've completed it to the best of your ability prior to watching this video so you can figure out where your misunderstandings are. When we're using the mole highway, we need to make sure that we have a balanced equation because we'll need the balanced equation for the mole-to-mole ratio to go from moles of one compound to moles of another. So if I begin by balancing this equation here, I would need 2 irons, and I would need, and I probably wouldn't start with iron, probably not the best idea, but here we go anyway. So 3 copper, 3 carbons, continue out, and I have 4, 2, 3, and I'm going to turn my annotations off really quick. So that is what my balanced equation should look like. The first question then asks me to write the mole-to-mole ratio between Fe2O3 and carbon. So if I look at Fe2O3, it has a 2 in front of it, so 2 for every 2 iron oxides, there are 3 carbons. Next, I see my fractions that are going to help me determine this. So if you have 4 moles of carbon, I need to always remember when I'm writing any sort of conversion, I start with my given over 1, so 4 moles of carbon over 1. How many moles of iron oxide will you have? Well, I'm going to go back, look at my mole-to-mole ratio. There's a 2 in front of Fe2O3 and a 3 in front of carbon. And again, I know that I'm getting that from the coefficients because I look at my mole-to-mole ratio from the balanced equation. Multiply that out, and I get 8 on top. 1 times 3 is 3, and I see my units have canceled. And then all I need to do is 8 divided by 3. And when I do 8 divided by 3 in my calculator, I get 2.667, and that would be moles of Fe2O3, because that's what I'm ending with. Next, number 4 asked me to find the molar mass of iron. I found that by looking at the periodic table, and I just need 1 iron, so that is 55.85 grams per mole. Remember, the units for molar mass are always grams per mole. Next, we can continue down and look at converting 2.5 moles of carbon to grams of Fe. I'm going to start again with the moles of carbon, which is my given, so 2.5 moles of carbon. I need to look at my mole-to-mole ratio. And how do I find a mole-to-mole ratio? Well, I know it's moles to moles. I'm looking at my balanced equation, so I look at my coefficients. The number 3 is in front of carbon, and the number 4 is in front of iron. Next, I have moles to grams. Anytime I have moles to grams, we're talking about, and this should actually be just moles of Fe because that's what it's going for. I could never go moles of iron oxide to moles of iron, or to grams of iron, so I'm sorry if that confused you. But anyways, anytime I'm going grams of one compound to moles of that same exact compound, I use the molar mass that I get from the periodic table. Well, the molar mass for iron we said is 55.85. There are 55.85 grams in 1 mole. Remember, molar mass is always per 1 mole. Next, I can multiply everything on the top together. So 2.5 times 55.85, that gives me 558.5. Divide that by 3 and get 186.17 grams of iron. There are multiple ways you could do that math. That's how I choose to do it. The next question, I need to find the molar mass of CO2. I find that just by looking at the periodic table. You did a wonderful job with that, so I won't go too much in depth, but the molar mass of CO2 is 44.01 grams per mole. This next one, I'm going from grams to moles, so I can review back to my mole to mole ratio. I'm going from grams of one thing to moles of another. So I'm going to start by putting my given over 1, so 78 grams of CO2. Next, if I'm looking at my mole highway, when I go from mass of something to moles of something else, I need to look at the molar mass. So I have 1 mole of CO2, and in 1 mole of CO2, that molar mass we said from the previous problem is 44.01 grams. Next, for moles of one thing to moles of another, I need to look at my coefficients. So I see from my balanced equation that I did earlier on, the coefficient in front of moles of carbon is 3, and the coefficient in front of CO2 is also 3. So I multiply that. I check to make sure my units have canceled. They have, and I end up with 1.77 moles of carbon. So that's my answer for that. Next, we're going to take a look at the backside. The quiz that you will have next class on Tuesday, notice that you will be expected to create fractions yourself. So your quiz will look pretty similar to this, not entirely, but where you will need to balance the equation, but then know how to write the fractions by looking at the mole highway. This mole highway will be given to you for your own benefit to help on the quiz. So for this next one, I need to find the molar mass of carbon, 12.01 grams per mole. Next, I find the molar mass for iron oxide, so I do 2 times 55.85 plus 3 oxygen, so 3 times 16, to get 159.7 grams per mole. For number 10, I'm going all the way from mass of one compound to mass of another. In order to do that, I need to stop at each point along the way. So I'm going to need to go from mass of carbon to moles of carbon. Once I have moles of carbon, I can switch elements by using the mole to mole ratio to go moles of iron oxide, and then end with my mass of iron oxide. I'm going to follow the same steps of starting with my given over 1. So I have 300 grams of Fe2O3 over 1. Then I multiply, and I know when I'm going grams of something to moles of something, as soon as I put grams of Fe2O3 on the top, I can put it on the bottom, so that unit cancels. I'm going from grams to moles of that same thing, so moles of Fe2O3. As soon as I put that on the top, I can put that same thing on the bottom. And now I'm going moles of A to moles of B, so moles of what I'm trying to find, which is moles of carbon, so I put that on top. As soon as I put something on the top, I can put it on the bottom. And finally, I'm going from moles of B, moles of carbon, to mass of that same thing, so grams of carbon. Next, all I need to do is plug in whatever those values are. So anytime I'm going from mass to moles, I look at that molar mass, and I know from above the molar mass of iron is there 159.7 grams of iron oxide in 1 mole of it. Next, I need to look at the balanced equation from the front side of the Bell worksheet. 3 goes in front of moles of carbon, 2 goes in front of iron oxide, and then I end with 1 mole of carbon on the bottom, and I have my 12.01 grams of carbon on top. I multiply everything on the top together, so 300 times 12.01 times 3, I get 10,809, so a really big number, but then I'm going to end up dividing that by 319.4, so I do 10,809 divided by 319.4 to give me 33.84 grams of carbon. And again, I would want to check to make sure all of my units have canceled out, and I see that that is correct. I'm left with grams of carbon. The answer to number 11 is 183.2 grams of CO2. Feel free to pause this video to get those numbers down if you didn't have them. Feel free to also rewind a little bit and look at number 10 because it's very similar to that if you want to know how I got any of the numbers. Next, this one is a little different because I'm going from moles of one thing. I'm going to erase that. I'm going from moles of iron, so I'm going to go moles of A to moles of Fe2O3, similar to one of the first ones on the front, but I'm following the same steps of starting with my given over 1, so Fe2O3 over 1. I need moles of Fe2O3 to cancel, so that goes on the bottom, and I'm going 2 moles of Fe. Pretty easy because it's just one step. We don't want to go too far. We never actually even need the molar masses or any of that. So I look, the number 4 is in front of Fe in my balanced equation and 2 in front of that. So 3 times 4 halves is going to give us 6 moles of Fe. And then finally, I'm going to look at moles of carbon. Number 13, I'm looking at moles of one thing, and I need to go to mass of another. So this is a little shorter than 10 and 11, but will still require me to write multiple fractions. Start with my given over 1, and I go grams on the bottom to get that to cancel to moles of the same thing. There's always grams of one thing to moles of that same thing. And then moles of Fe2O3 to moles of carbon. Notice I stop here because I'm going mass of one thing to moles of that same exact, to a different, mass of one thing to moles of another compound. I don't ever need to find the mass. So I want to make sure I don't go too far, and I could check that by when my units cancel, I'm left with moles of carbon, which is what I want. So our molar mass for Fe2O3 is 159.7 grams, and there are that many grams in 1 mole. Then I look at my mole to mole ratio to see the number 3 goes in front of moles of carbon and 2 in front of Fe2O3. Multiply that out. 35 times 3 equals 105, and then divide that by 159.7 times 2 to get 0.33 moles of my carbon. I can pause a minute, make sure that with some ballpark estimates, does that answer make sense? It does, so we're good to go. The rest of class, you'll be reviewing these concepts by checking your homework and then doing some more practice in the in-class practice packet that you got last class, and then ending with the notes from last class and finishing those practice problems. Your homework will be a teacher made. If you have any questions while you're completing these or need to see any more explanations, again, please don't hesitate to reach out, to ask a friend, or come to office hours on Tuesday morning. I hope you have a wonderful day, and I hope Mole Highway is beginning to make a little bit more sense. Bye.